All right, let's get a little practice with finding critical values. Okay, so that's where the derivative is equal to 0 or undefined. So we'll begin with the first example, 1/8. So take a derivative. And that would be 3x squared minus 12x plus 9. All right, this is never undefined, so I can skip that. It is equal to 0. There are values for which it's equal to 0. So let me divide out a 3 from both sides, reducing this down to x squared minus 4x plus 3 equals 0. And I could easily factor that to x minus 3 times the quantity x minus 1. And that gives me two roots. So I have two critical values at x equals 3 and x equals 1. These are my critical values. All right, so in general, I probably will just abbreviate that critical values as CV. Okay. All right, how about for this function here? All right, I'm going to rewrite that as a power. So that's x minus 2 to the minus 1, and now take a derivative using the power chain rule. So -1 times my base, which is x minus 2, and then subtract 1 from the exponent, which is going to give me -2. And then I multiply by the derivative of the inside, which is going to be 1. And then if I rewrite that, I have -1 in the numerator and the quantity x minus 2 squared in the denominator. Now, since the numerator is a constant, this first derivative will never equal 0. However, there is an undefined value in the denominator at x equals 2. So g prime is undefined at x equals 2. And so that's my critical value. All right, let's take a derivative of this. Looks like I'm going to need to do a quotient rule. H prime of x. All right, so derivative of the numerator, power chain rule, 2/3 x minus 2 and subtracting 1 to the -1/3 times the derivative of the inside, which is 1. And then that's the derivative of the numerator times the denominator, so we multiply by x. All right, so that's low d high minus high d low, right? So the high at the upper, the numerator function, multiplied by the derivative of the denominator, which is 1. And then we divide the whole thing by the denominator squared. All right, so how am I going to simplify this? I have this next. This will be a complex fraction, right? So I am going to, let me simplify this a little bit. So I have 2 over 3 times x minus 2 to the 1/3. 2x. So I need an x up here. So it's just simplifying this term a bit. And then minus, and then we have x minus 2 to the 2/3, all divided by x squared. All right, so complex fraction, right? So I'm going to need to clean this up a bit. And so I'm going to multiply the numerator by that denominator, which is 3 times x minus 2 to the 1/3. And then I do the same in the denominator, 3 times x minus 2 to the 1/3. And that gives me, all right, so in the denominator, that's easy. All right, so 3x squared, x minus 2 to the 1/3, the cube root of that, right? All right, and then, so here I have to distribute. So I'm going to multiply the first term, right, times this quantity, and then I have to multiply the second term. All right, so if I multiply 3 times this this times the first term, notice the denominators will just cancel. So this 3 will cancel, the denominator will cancel with both of these, leaving me just 2x. Yay, that's simple. All right, and then I multiply this quantity times this term. Well, I'll still have the 3, so it's going to be minus 3. And since these are the same base, I can just add the exponents, 2/3 and 1/3. And multiplying like bases, you add the exponents. So that's going to be to the 3/3 or 1. So that's 3 times x minus 2. See how cleaned up that is? Oh, love it. Okay, so this is 2x, and then I'm going to combine like terms and all of that. If I distribute this, I get negative 3 times x, so negative 3x, and negative 3 times negative 2 plus 6. So now I can combine my like terms. 2x minus 3x is negative x, and then plus 6. All divided by 3x squared x minus 2 to the 1/3. Okay, now we haven't even answered the question. That was just getting that first derivative, right? Okay, so now let's answer the question. What are the critical values? The critical values are where the function is equal to 0. So since this is a rational function, that's where the numerator is equal to 0, and that would occur when x is 6. So at x equals 6, we have our first critical value. All right, the other critical values come from when the function is the first derivative is undefined. So in the denominator, that would be when x is 0 here, and this contributes a critical value when x is 2. So x equals 0 and x equals 2. All right, so just to kind of review, the first one is when f prime equals 0. And these two came from finding where f prime was undefined. All right, so that's finding critical values, and that would